Okay, you guys, so now that we've introduced ourselves to circular functions, what I like to do is take a look at what is famously known as our unit circle, all right? And really what this does, it just gives us another way to memorize our special angles. And what I'm going to do is tie this in to what we've done before and just hopefully prove to you that it's just it's not anything groundbreaking, it's not anything earth-shattering, it's just basically another way to memorize special angles. So if we're not working with special angles, the unit circle is actually useless. So this all applies to special angles, and of course what are those? 30 degrees, 60 degrees, 90 degrees, right? 45 degrees, 45 and 90, all right? And all their coterminal angles. I think 180 is there. We're essentially talking about all the quadrantal angles. So anything special, and we've already done all this before, right? We did that with XYR definitions. We found them with right triangles, and we're just going to basically repeat the same thing. And I'll tie things together real quick. But what I like to do, first of all, as we go around this unit circle, let's try to map it out as best as we can, and then I'll tie some ideas later. Some points that we know for sure. This is the x-axis and that's the y-axis. So this is the point 1, 0, right? This is the point 0, 1. This would be the point negative 1, 0. And this would be basically the point 0, negative 1. And in terms of angles, right, how about on the edge here, this would be 0 degrees. And outside here, it would be 0 radians. And as we move along, I'll come back to these in a moment. But at this, right, it was 90 degrees, which we know to be pi over 2 radians, right, in radian mode. Back over here, this is 180 degrees, but we know that to be pi in radian mode. And moving around to our other quadrantal, right, this was 270 degrees, which we know to be 3 pi over 2. So again, all we're basically doing in this unit circle is looking again at things we already know, all our special angles. So hopefully this is just a reinforcement of something we've already done. So what about all these other ones? What I'd like to do, let me come up here, all right, is let's take a look at our special angles, right? So our special angles, our special right triangles were something like this, right? This was 45, this was 45, and we had our right angle. And we knew, right, that if this side was 1 and this side was 1, then that ratio was the square root of 2, all right? This being basically our r, this being our x, and this being our y. However, we need to be on the unit circle, right? R needs to be equal to 1. So to accomplish that, right, to get what we need, since I want to eventually be on the unit circle, I have to let r not equal the square root of 2. I've got to let r equal 1. Well, it's very easy to do. I'll just take this and divide that by the square root of 2. Of course, if I divide that by the square root of 2, I got to divide everybody by the square root of 2. And so our new right triangle, kind of scaled down if you would, is that this radius now is 1, right? There's the right angle in the 45. This is now 1 over the square root of 2, and we know, you guys, I know I'm a pretty big stickler on rationalizing the denominator, and this side's also 1 over the square root of 2, and so we get square roots of 2 over 2. And so tying this to our unit circle here, right? Now that my radius is 1, that would be, I know it looks a little bigger, but that would basically be this right here, this angle that we're forming there. We know that to be a 45-degree angle, and in radian mode, that's pi over 4. And the x-coordinate here would be the square root of 2 over 2, and the y-coordinate here would be the square root of 2 over 2. Just imagine if we're going to be taking this picture, right, and superimposing it right there, right? So there would be the x value of the square root of 2 over 2, the y value would be the square root over 2 over 2, right? And the radius would be equal to 1 since I'm on the unit circle. So again, this is just telling us something we already know, that here's the cosine of 45 and here's the sine of 45 that we found ages ago using other math. It's just, again, another way to memorize it in the conjunction of a unit circle. And of course, I think you guys can know that the next ones, right, are pretty much our other angles. So let's go take a look at that type of triangle, right? So we have 30, we have 60, and we had 90. So for this, right, this side over here was 1, this side was 2, and this side was the square root of 3. And again, this is essentially what our radius is. This is our y value, and that would be our x value, right? If we're using our old, sorry about that, I was off the screen there. If we use our old definition. However, to tie it into my unit circle that's down here, I need r to equal to 1. So I'll just come up here, my r is currently 2, so if I divide that by 2, and being consistent I have to divide every else by 2, I've created something that is on the unit circle. And it's maybe a little out of whack. There's 30, here's 60 and 90 still. This is 1, this is the square root of 3 over 2, and that's 1/2. So there's your x, and there's your y, and there's your r. So superimposing that picture down here, right, we are now talking about a 30-degree angle, right, which we know radian mode is pi over 6, and the x-coordinate is the square root of 3 over 2, and the y-coordinate is 1/2. So there's your cosine value of 30, or pi over 6, and there's your sine value of 30, or pi over 6. Again, stuff we already knew using right triangles and other definitions. What about this guy? Well, we already know that's 60 degrees, right, which is pi over 3. But if we drew a picture of this guy, let me bring this down. So if we drew a picture of this guy, there's my 60, there's my 30, right? This is 1, this is 2, and that's square root of 3. So here's my r, here's my x, and here's my y. And so again, because we're on the unit circle, I need my r to be 1. So I'll divide that by 2, divide that by 2, divide that by 2, and we get the new similar triangle, right? Here's 60, here's 30. This is now 1, this is 1/2, and this is square root of 3 over 2. So my r is 1, my x is 1/2, right? And my y is square root of 3 over 2. And so superimposing this picture, right? This right here, right? My x coordinate is 1/2, my y coordinate is the square root of 3 over 2, right? And we're talking about 60 degrees. So again, the sine of 60 or pi over 3 is 1/2. Excuse me. The cosine of 60 or pi over 3 is 1/2. The cosine, or the sine of 60 and pi over 3 is square root of 3 over 2. And so we basically, right, have reworked, right, basically our cosine and sine values throughout the whole first quadrant. And that's something we did way back in chapter 1, actually. It's nothing new. It's just we're organizing, right, our special angles and their trig values within the unit circle. And I guess it's a memory aid, you know, perhaps that helps you guys remember some things a little better. But again, I want to remind you, right, if we're not using special triangles, right, we're still using the unit circle, right? Every x, y is cosine and sine, but, you know, we're going to have to do other math. So this is, again, the unit circle, for as cool as it is, and you know, for as people think it's the nadir of trigonometry, it's not, because all it does is basically organize your thoughts for special angles, and we've been doing that a long time anyways. So nice memory aid to have. It's really good to help memorize our special angles and their cosine and sine values in terms of x and y. And we'll obviously use that, but we've been doing it all along anyways. I've been forcing you guys, right, to find the exact values of cosine of 45 and sine of 60 and tangent of 30. So hopefully it just reinforces what we've been using anyways, and we're just reinforcing it. We obviously have 3 more quadrants to talk about, so we're 8 minutes into this, so I'm going to pause and we'll come back in another video and we'll refill, right, the rest of our unit circle.